Hey everyone, welcome back to another video about physics past papers for CIE A-levels syllabus. Today we're going to talk about the paper 1-1 of the May June 2025. Again, before we dive into the paper, let's first see the resources that we have created for you, which are going to be used in these physics videos. So we have already packed them in this Grade Booster pack and it's available on Patreon. So what it includes for AS, it includes definitions and formulae. So if we see this below, it contains all the necessary key points, formulae. Then we have important derivations that are required by the syllabus and the ones that often come in paper 2. Then we have the frequently examined questions, which is slightly more important, paper 2 questions. Then, since this is also about A2, we also have similar things for A2's definitions and formulae, key terms, their formulae. Then important derivations. Again, we know that paper 4 does come with derivations often. Then this one, A2 frequently examined questions, this is slightly more updated. As you can see on the left hand side, we have syllabus points, the relevant questions in the next column, answers aligned with marking schemes in the next, and the years listed at the right side. As you can see, there will be some questions that have a lot of years written on side of it. That would mean that they are very frequently examined questions. Then we have important graphs. We know we all struggle with field and potential graphs for gravitational and electric fields. So we have got you covered on that. Then last but not the least, we have the paper 5 planning questions practice. It contains a checklist according to the marking schemes and the syllabus. And we also have some work example questions from the past paper, recent past papers. This is the diagram, this is the procedure and everything. Although it's arguably not possible to fit everything in the space given, but it still shows you what details, what you can include, how much thorough you can be, how much careful you can be, and everything. That's it. Okay, now let's go back to the paper. All right. All right. Which quantity is a vector quantity? So let's see. Pressure is not, temperature is not, weight is a vector quantity, work is not. So weight is the only answer. Okay. 4 students A, B, C, and D have completed their experiment to determine the acceleration of free fall G. Each student repeated the experiment 3 times. Determined values of G are shown in the table. Which set of results has a high precision and a low accuracy? So precision means that the values are close to each other. So precision means values or measurements are close to each other. Whether they are accurate or not, that's not the point. Accuracy means basically the difference between measurements and actual value. Lesser the difference, more accurate. So what we need to see over here is precision would mean, so what we need to see over here, how close the values are clustered with each other and what is the difference of the average of those values from the accurate value, from 9.81. So 7.2, 9.4, 8.3. There's a very low precision over here. So we can actually clear it out right away. So this is not answer. 9.5, 9.8, 10.2. They are somewhat close to each other, but as you can see, the average would still be close. So 9.5 plus 10.2 divided by 2, this is still 9.85. So still good accuracy, but obviously not high accuracy, but still fine. So no, 9.8, 9.8, 9.9. So this is high precision, high accuracy, so not the right answer. 10.1, 10.2, 10.1. Now these values are close to each other, but they're not accurate. They are far from the actual value. So D would be the right answer. All right. The diameter of the ball is measured as this. What is the absolute uncertainty in the volume of the ball? So for this, we need to find out the percentage or the fractional uncertainty in the V, and we also need to find out the V itself. So volume in terms of diameter for a sphere is 4 over 3 pi r cubed, but r we can write it as in terms of d over 2 whole cubed. So in fact, we can write it as 4 over 3 pi d cubed over 8. You can further simplify this as 1 over 2, but you can leave. Okay, so 4 times by 2 is 8, so 3 times by 2, 1 over 6 pi d cubed. Okay, now we need the volume. So volume would be 1 over 6 pi. D is given as 5.26 cubed. So pi divided by 6 times by 5.26 cubed. So this is given as 76.2 centimeter cubed. Now we need the delta V over V. As we can see, this would be the same as delta D over D times by 3 because it's D cubed. But we still need to figure out. Oh, okay. Sorry, I thought maybe it was the radius. Sorry, we don't need that. So if in case the radius was given, we know radius times by 2 is d, so we would have actually needed to multiply the uncertainty of d with uncertainty with r for that absolute one, not the fraction. So diameter is already given, so we just need to multiply by 3. So 0.02 divided by 5.26 times by 3. So 0.06 divided by 5.26. This would be 0.011 that 4, let's call it. So absolute uncertainty would be fractional uncertainty times by the volume, 76.2. So this times by 76.2, we get 0.869. We can write it as 87. That's it. Right. Okay, moving on. Two vectors x and y are shown. What are the directions of x plus y, x minus y? So x plus y would mean that first off we go from x to this is your x, and y would be following in the same direction. So this would be your y. So this is x, this is y. So the resultant would be in this direction. This is x plus y. So x would be going this way, minus 5 minus y would be going opposite direction but same length. So opposite. So this is minus y, x. So x minus y, what are we doing over here? We can also write it as sum of x and minus y. So the direction over here comes slightly, I think, vertical. So this is x minus y. So I think B would be the right answer. Right. Okay. Moving on. A ball is projected vertically downwards with an initial velocity of 20 meters per second. Air resistance is negligible. What is the displacement from its initial position of the ball after a time of 1.5 seconds? So it is projected vertically with a speed of 20 meters per second, and we need to find out how much distance it covers after it has traveled for 1.5 seconds. So we can use S is equal to UT plus half AT squared. U is 20 times by 1.5, and half A would be 9.81 divided by 2 times again 1.5 squared. So all we need is to just put it in this. 20 times by 1.5 plus 9.81 divided by 2 times by 1.5 squared. Also, we get 41. That's it, simply. Oh. A server's device emits a pulse of light. Light is reflected from a wall 150 meters away. What is the total time for a pulse to travel from the device to the wall, then back to the wall, then back to the device? Okay, so first let's do this in seconds. We know that V is speed of the sound, speed of light is 310 raised to power 8 meters per second. Distance, total distance that we have is not just 150, it's 300 meters because it's traveling twice that amount. So the time would be S over V, 300, 310 raised to power squared, and 310 raised to power 8. So this cancels out. We are left with 10 to minus 8, which is 10 raised to power minus 6 seconds, also equivalent to 1 microsecond. So 6 is D. Which equation of uniformly accelerated motion can be derived using only the gradient of the velocity time graph? Now let's see. Which equation of uniformly accelerated motion can be derived using only the gradient of the velocity time graph? Only the gradient. Okay. So the gradient of velocity time graph gives us change velocity over change in time. So basically this is like v minus u over t, and which is equals to a. So if we cross multiply, this becomes v is equal to u plus at. So C is the right answer. An object is projected horizontally from a table at time t is equal to 0. Object falls in uniform gravitational field. Air resistance is negligible. Graphs PQ, R, and S are velocity time graphs. Which graph represents the horizontal and vertical components of the velocity of the object? So first off, horizontal remains constant. So horizontal would be Q. This would be horizontal. So that means the R and R will cancel out. Now, the vertical one, since it is being projected like this, so the vertical velocity will increase by v is equal to u plus at root. So uniform acceleration. So u is 0, projected horizontally. So Vy Uy, so U is equal to 0 plus AT, so V is equal to AT. So sort of like Y equals to Mx, so straight line. So straight line is only P. So this is your vertical. So P would be Q and P would be the right answer. Okay, moving on. What is always conserved in elastic collisions? Total kinetic energy? Yes. Total velocity? No, no. Kinetic energy conserved. Right, okay. Uh, right. A firework travels vertically upwards in air. Gases are pushed vertically down from the firework. Several forces that act on the firework and the gases are shown. So weight of this, force on gases, air resistance, thrust. Which forces are a Newton's third law pair? The word play over here is very evident over here. So force on gases. So force on gases, and that is actually what's causing the thrust. So thrust and force on gases. These ones are the Newton's third law pair. So Newton's third law pair, remember they're equal opposite forces, but they act on different objects. So that's basically it. So force on gases and thrust. Okay. Two blocks K and L slide towards each other along a horizontal frictionless surface. During the collision, blocks are in contact with each other for a time of 0.084 seconds. After the collision, the blocks are in contact. Oh, sorry, no, sorry. After the collision, the blocks separate, and block L moves along this original path with the momentum of this. Block L. Okay, right. What is the magnitude of average force exerted on block L by block K during the collision? Now, a common mistake over here is where students misunderstand the word moves back along its original path. It does not say moves back its original direction. It does not say that. It says moves back along its original path. That means it's going in this direction. So now, if we take this direction to be positive, the final momentum PF is 0.12, and P initial is going to be, we're going to take it negative because this was in the opposite direction, so minus 0.46. Now, another thing, the change in momentum experienced by both of these objects would be same in magnitude but opposite in direction. So if we can find out for one of them, we can find out for the other. And likewise, the force will be the same also. So change in momentum is going to be equal to final minus initial. So 0.12 minus 0.46, which means just simply 0.12 plus 0.46. This would mean 0.58. Now we need the force. Force is rate of change of momentum. So 0.58 divided by 0.084, which is given. So 0.58 divided by 0.084, and that is 6.9. That is C part. Okay, all right, moving on. Leonardo da Vinci proposed a flying machine that would work like a screw to lift the pilot into the air. Screw is rotated by the pivot. The machine and the pilot together have a total mass of 120 kgs. Which useful power output must the pilot provide to move vertically upwards at a constant speed of 2.5 meters per second? Okay, So the over here, the keyword over here is at constant speed. So that means that the work done, uh, work done against gravity is the minimum thing that we what we need. This would be what we simply need first. So total mass is 120 times by 9.81, and this is the force, this is the weight. Okay, so this is F, and uh, we don't have S, no? All right, sorry. So we can say power, basically, we can convert it into FV. So F is again mg, 120 times by 9.81, constant speed of 2.5. That would be the equivalent to same thing. So 120 times by 9.81 times by 2.5, 2943, so roughly around 2900. So this is the answer. Okay. Which row describes a pair of forces that form a couple? So couple, direction is opposite, but magnitude, they are equal. So direction is opposite, magnitude of force is equal. So 13 is B. Okay. A uniform cylinder of weight 25 newtons is suspended from Newton meter. Cylinder is fully submerged in water. The reading on the Newton meter is 10 newtons. The water is replaced by a liquid with a density 10% greater than the density of water. The cylinder remains fully submerged. What is the new reading on the Newton meter? Okay, so first off, we need to understand why is exactly happening. So this is the weight, and in this direction it is the upthrust. So the difference between them now is shown as 10 newton. So weight minus upthrust is shown as the effective weight, that is shown as 10 newton. So weight is given as 25 newton, so upthrust would be 25 minus 10, which is 15 newton. And if it stays completely submerged, upthrust would remain the same. So now we are using a liquid with 10% density greater than the density of water. So that means the new one is, let's say liquid is 10%, that means 1.1 times by density of water. So what is going to change? The upthrust is going to change. So upthrust is rho GV. Rho is always the density of the liquid. So it would be 1.1 density of water GV. This remains the same because it's submerged. Only thing that's changing is this. So upthrust has now increased 10% also. So upthrust increases by 10% also. Now, if upthrust has increased 10%, this would be 15 times by 1.1. So, oh, sorry, no. 15 times by 1.1. This would be 1. Sorry, no. 16.5 actually. Yeah, 16.5 newtons. So this is the new upthrust. So that would mean that the resultant force over here, this would be shown as 25 minus 16.5. So 25 minus 16.5 will be shown as 8.5 now. So 8.5 is part A. Right, okay. Moving on. A student balances a 30 centimeter ruler on a fulcrum set at 15 centimeter bond. This is the 15 centimeter mark. She then places a 50 gram of mass at 23rd centimeter mark and a 20 gram mass on the 11 centimeter mark. Which mass should she place on the 7 centimeter mark to restore the balance? Okay, so first off, she already balances it by placing the fulcrum at 15 centimeter mark. So this shows that this was a uniform ruler. That means this was the center of gravity point already. So we need to figure out where it's leaning first, and then we can see how what mass we can use over here. So anti-clockwise is equal to clockwise. So moments counterclockwise, sum of moments clockwise. So counterclockwise are these ones. 7 times by no. 15 minus 7, 8 times by m plus this is 15 minus 11, 4 times by 20 equals to 23 minus 15, that is 8 times by 50. So 8 missing mass plus 80 is equal to 400. So 400 minus 80 is 320. So 320 divided by 8 would be 40 grams. Simple math. Okay. A submarine is at a depth of 130 meters below the surface of the sea. So submit over here, 130 meters. The pressure on the submarine due to the seawater is P. The submarine sinks to a depth of 260 meters below the surface. Assume that the density of the seawater is constant. What is the difference between the pressures on the submarine due to seawater at the two depths? So the thing to notice over here, if we say this is height equals to 130, 260 meter would be then 2h. So we know that the pressure is written as rho gh at 130 meters. This is going to be the case. But at the 260, you would have same rho g, but 2h. So this would mean that this is 2p. So at 260, this would be 2p. So difference in pressure would be just 2p minus p, that is just p. C. An object is falling in a uniform gravitational field. Which two quantities are sufficient to calculate the change in gravitational potential energy? So change in gravitational potential energy, EP, is just mgh. We need the mass, h, and g. So we need 2, not 3. So mg is basically the weight, and height is the change in displacement, you could say, is what we need. So weight and change in vertical displacement. This is sufficient information. So when we had mass, we would also have to include the acceleration of free fall and in height. But weight already encompasses mg, both of them. Okay. So the points x and y are on a rough horizontal surface. Box P is pushed across the surface from x to y and then from y to z. The distance from x to y is 3 meters. Work done against the frictional force in moving the box from x to y is 150 joules. Work done against frictional force in moving the box from Y to Z is 200 joules. An identical box Q is pushed along the straight line X to Z. The magnitude of frictional force between the boxes and the surface is constant. How much extra work is done against the frictional force in moving P then Q? So if we can calculate one of them, we can find out the magnitude of frictional force, and then we can find out the distance from Y to Z also. So we know the work done is F times by displacement. Work done against frictional force from X to Y is 150. Frictional force is unknown. Displacement is 3. Frictional force would be 150 divided by 3. So that would be just 50 newtons. As they have already said that the magnitude of frictional force between the boxes and the surface is constant. So 50 newtons frictional force in all three possibilities. Next up, we need to know the YZ distance. So the work done is 200. Frictional force is 50, but we do not know the S. So S would be simply 4. 50 times by 4 is 200. So this is 4. Now, we need to compare with XZ. So XZ would be the square root of 3 squared plus 4 squared. We're talking about the distance. So 9 plus 16, this is 25. 25 square root is just 5 meters. So the work done would be F times by S, 50 times by 5, which is 250. This is from X to Z. But the total work done from X to Y to Z is 150 plus 200, that is 350. So how much extra work would be? That would be just 350 minus 250, that would be just 100. So 18 would be A. All right. The momentum of a car of a mass m increases from P1 to P2. What is the increase in kinetic energy of the car? So kinetic energy expressed in momentum is half P squared over m. So, or simply just P squared over 2m. Now, m remains the same, obviously, but the momentum changes, so change in kinetic energy would be half 2m pf squared minus p initial squared. Well, they already gave us p1 to p2, sorry, so this would be then final minus initial. 2 minus 1. So this would be A. So they are already squared, so 19 would be A. All right. A parachutist is falling at a constant terminal velocity. Which statement is not correct? Gravitational potential energy is converted into kinetic energy into the air. This is still correct. Actually, sorry. This is still correct. Gravitational potential energy is converted into kinetic energy of the parachute. So one thing to notice over here is that the change in EP and the change in kinetic energy, this only works when you have a conservative system. That means there's a constant change in mgh and a constant change in half mv squared. So if this part is 0, so if this part is 0, then that means the gravitational potential energy is also the same thing. This means that the gravitational potential energy is not being converted for the kinetic energy of the parachutist. So a kinetic energy of the air does not matter. what is not correct is gravitational potential is converted into kinetic energy of the parachutist. This is not happening. So 20B is correct. Gravitational potential energy is converted into thermal energy of the air. Partly correct. Is converted into thermal energy of the parachutist. Partly correct. Converted into kinetic energy of the air. Partly correct. Okay. A student investigates a spring. The variation of length of the spring with the force applied to the spring is shown. What is the spring constant of the spring? Okay, so first off, F is equal to kx, and k would be F over x. X being the extension, not the length. So extension is 0 over here, and extension is 0.4 over here at this point. So this is what we need. So the change in force over change in extension. Change in force is 2.4 and change in extension is 0.4. So I think that would be 6, but 2.4 divided by 0.4, 21. Right, so 6. The graph shows the variation with force of the extension of the wire. The force is gradually increased to a maximum at Q and then gradually decreased to 0 at R. Which statement is correct? Along the line PQ, the wire obeys Hooke's law. No, Hooke's law means straight line. It would be from 0 to P basically, if we want to say Hooke's law. Along the line RP, spring constant is equal to extension over force. That would be correct because in that case, F would be equal to Kx. Force is directly proportional to extension, whatever you want to call it. So that would be correct. No, wait, sorry, RP. RP, spring constant is equal to extension over force. Sorry, no, my bad, no. Extension over force would be 1 over K. So, no, sorry, this is also not correct. So it would be equal to the reciprocal of spring constant. Wire has elastic deformation at point Q. Elastic deformation at point Q. Okay. Elastic deformation means that once the force is removed, it goes back to its original dimension. So when the force is removed, it goes back to its original dimension. So that is correct. Work done in stretching the wire to P is equal to force times by extension at point P. No, because that would be the area and this would be half times by Fx. So this is not correct, this is not correct, this is not correct. So C is the only thing that's correct. All right, moving on. A uniform metal wire of length L and a diameter D has spring constant K. What is the Young modulus of the metal? So Young modulus is stress over strain. Stress is force over area. Strain is extension over the original length. F over A L X. Okay. F is equal to Kx. So once we replace that over here, this would become KL over A. Okay, and cross-sectional area is pi d squared over 4. So once we replace this inside, you will have 4kl over pi d squared. So that would be D. Right. An aircraft produces a sound at a frequency 30 hertz. Speed of the sound in air is 330 meters per second. Aircraft is directly above the directly in front of the stationary observer and travels in a straight line towards or away from the observer. Observer hears the sound from the aircraft at a frequency of 20 hertz. What is the speed and direction of the aircraft? Now, this is Doppler effect. So what's happening over here is that the observed frequency is less than the source frequency. So this means that object is receding from the observer or going away from the observer. So that means right away we don't even have to look at them. The next question comes about the speed. So how do we select the speed? So in the Definitions and Formulae booklet, for receding source, we already know that observed frequency is lower. We also know the source frequency. We just need to figure out what's the velocity of the source, okay, which is Vs. V is the original speed of the wave, basically. So F naught is equal to V over V plus. By the way, this particular formula is also available in the data sheet at the start of the exam, but it's plus minus. So if you don't know whether you're looking for the away or the towards, you might get confused. So we know F naught is 20 equals to V over, sorry, we already have 330. 330 plus Vs, which is unknown, and F, original source frequency, we can bring over here. So 2/3 and then cross multiply. So 2 times by 330 plus Vs equals to 3 times by 330. So 2 times by 330 is 660 plus 2 Vs equals to 990. So 2 Vs is equal to 990 minus 660, which is just 330. So Vs is going to be 330 divided by 2. So 150 plus 1, 6. Yeah, sorry, 150 plus 15. Yeah, so 165. Yes. So 330 divided by 2, that is 165. Right. So C is the correct answer. Right. Okay, moving on. Which statement about the longitudinal and transverse wave motion for a progressive wave is correct? All transverse and longitudinal waves require a medium for propagation. No. Transverse waves travel at the same speed, but longitudinal waves can travel at different speeds. No. In both transverse and longitudinal waves, a particle with zero displacement has a maximum speed. That is the only thing that is the correct one. Because a particle with zero displacement, its rate of change will be maximum. So this is the correct. In longitudinal wave, there is a net movement of particles in the direction of travel of the wave, but there is no net movement of particles in the transverse wave. This is stationary, so we don't have, obviously that's not progressive. Okay, on the diagram shows a progressive transverse wave on a stretched string at one instant in time. One point on the string is labeled as x. On which point on the string is 270 degrees out of phase with x? Okay, so from x, B is 90 degrees, C is 180 degrees, D on the other hand is 360 degrees. That means almost, it means 0. This could also be taken as 0 also because there is no phase difference between x and D. They are in phase. However, if we look at A, so 90, 180, 270, A is the right answer. which wavelength of the electromagnetic radiation in free space could be the green light? Right. So just to show you, otherwise you should actually remember this also. Over in the reasonable estimates, no, sorry, in the waves. Actually, this was in the waves. In the waves, in the electromagnetic, visible spectrum goes from 400 to 700 nanometers. And how to figure out which color lies in this? So we have Roy G. Biv. This starts from 700 and it decreases by 50 each. So 650, 600, 550, 500, 450, 400. These are all nanometers. Could be green is in 550 nanometers, which is actually 5.5 10 raised to the power minus 7. Which group contains only waves that can be polarized? So polarized transverse waves. Infrared are electromagnetic, so transverse. Radio waves, transverse. Sound waves, no. Visible light waves, transverse. Microwave transverse. Radio wave transverse. Yes, so 28B. Okay, so one wave has an amplitude of 2A. The second wave has an amplitude of A by 2. The waves are otherwise identical. Two waves travel in opposite directions and overlap. What is the ratio of the maximum amplitude of the combined wave and the minimum amplitude of the combined wave? So what we can do, it's simple principle of superposition. So they will either add up or they will either subtract. So 2a plus a by 2. This is actually 5a over 2. This is simple math. You should be able to do that now. And 2a minus a over 2. This is 3 by 2. 3a over 2. Now, if we divide them, both sides, maximum, minimum, you can see that a, 2, 2 get cancelled, leaving us only 5 over 3. Light of wavelength 680 nanometers is incident normally on diffraction grating with 450 lines per millimeter. What is the angle of diffraction in the second order maximum in the diffraction pattern that is produced? Okay, so first off, we need to figure this out. 450 lines per millimeter. So the line spacing would be 1 millimeter, which is 10 raised to power minus 3 millimeter and 450. So this would become 1 divided by 450 divided by 1000. So in short, let's do this in this standard form. So 2.2 10 raised to power minus 6 per meter. And 680 nanometer, you can convert it into meters by that simply. Now, we have n lambda is equal to d sine theta. So we need to figure this one out first. So sine theta would be n lambda over d. We need second order. Wavelength is given to us as 680 10 raised to power minus 9 divided by d, which is 2.2 10 raised to power minus 6. Now, 2 times by 680 times by 10 raised to power minus 9 divided by answer. This is this thing. And now we just need to do the sine inverse. So sine inverse of answer is going to be 37, basically. 37.7, so we can actually convert this into this form. So 38. That this would be the right answer, up to 2 significant figures. All right. A hollow tube is closed at one end and open at another. Stationary sound wave of the lowest possible frequency. This is the threshold frequency or fundamental frequency, sorry, because the lowest possible frequency that can make a stationary sound is called fundamental frequency. It's produced in the tube. Speed of the sound is this. Okay. So what's happening over here is you have this, and this is what you have at the moment. So actually we should change the color of these. Never mind. Let's do it one by one. This, nope. This and this. Okay. So this is your antinode, this is your node. This is the lowest possible stationary wave that can be produced when it's closed at one end and open at another. So we know the distance between node to antinode is lambda by 4. So if lambda by 4 is this, let's see what else we need. Fundamental frequency is given as 820 hertz. Speed of sound is this. What is the length of the cube? Okay. So speed is f lambda, right? And lambda, and this thing we can rename it as length of the tube. Basically, this is the length. So lambda is 4L. So we can replace it by that. So we have frequency, which is given to as 820 times by 4L and 330. So L would be 330 divided by 820 times by 4. So 330 divided by 820 divided by 4. So that is 0.1 meters, which would be 10 centimeters. Which expression gives the definition of resistance? So resistance is basically V over I. So current divided by potential difference? No. Current multiplied by potential difference? No. Potential difference divided by the current? This is the only thing that's correct. The graph shows the IV characteristic of the electrical component. What is the electrical component? This is very easy. This is just a diode. So when the current is flowing in one direction, it does not allow the current to pass through, and after some threshold voltage, it allows the current to pass through. So this is semiconductor diode. These are the things you will have to remember. The diagram shows 6 identical resistors connected in a circuit. In which branch of the circuit is the most power dissipated? That means in which branch is the most resistance. That's what the answer is. So if all are identical resistors, let's call them R. So from P to Q, we will have 2R. Q to R is just simply R. P to S is just simply R. But S to R is R by 2 because they are in parallel with each other. So PQ, QR, RS, and SP. SP is R. So to understand that, we need to look at both the V across the PR and the current through PR. So from P to R, the total resistance is 3R. But from, PQR, we should say. PQR. But in PSR, you have R plus R over 2. which is 3 by 2R. Exactly half of that, right? So this means that more current will flow through. Current in PSR is going to be more than in current PQR. Right? So even the squares of those values will be the same. PSR whole squared I PQR whole squared. We could deduce the expressions for PSR and PQR also very quickly. So let's say if this is V, so IPQR would be just simply V over 3R, and IPSR would be V divided by 3 by 2. So that would be 2V over 3R. 3, sorry, my bad. I don't know why it's not working. 3R. That means it's twice as big. Okay, so that's twice as big. So we don't have to do this. So let's test out each branch now. So PQ V over 3R times by I squared R. So this becomes V squared over 9R squared times by 2. So 2V squared over 9R. Similarly, same thing, V over 3R whole squared times by R. So this would be V squared over 9R. This one, we have 2V squared over that. So 2V 3R whole squared times by R. So this becomes 4V squared over 9R. This, on the other hand, becomes 2V over 3R whole squared times by R over 2. So this becomes 4V squared divided by 2. So that's 2V squared over 9R. So the highest we see over here is in PS. So, or SP, this one. So first we figured out in which branch the higher current is. This one, basically, we already knew about this. We even before we deduced it, before we found the expression for that. And after that, between PS and SR, PS has the higher resistance. So that's where the most power dissipation will be. So we could have done this by simple reduction, but just to show you the understanding, just to show you the foundation where it actually comes from, that's this. All right. The diagram shows a circuit containing a thermistor, a fixed resistor, and a battery. The graph shows IV characteristics of both components. Fixed resistor containing a thermistor, a fixed resistor, and a battery. Okay. The battery has an EMF of 12 volts, negligible internal resistance. What is the current in the fixed resistor? So fixed resistance is this one. This is the thermistor one. So we need the battery. Battery has 12 volts. So instead of trying to calculate from the start, let's do it backwards. So we know that the potential differences, according to the Kirchhoff's law, V1 and V2, they should be equal to 12 volts. So given the current, we can deduce the potential differences, and if those potential differences add up to 12, we can just find the answer. So this is why the graph is given to us. So 0.36. So 3, 6, first let's figure out what the this is. So 0.2 is covered in 0.5. So 0.2 divided by, oh sorry, no, that is 0.04. So 0.04. So 0.36 divided by 0.04, that is 9. So this is the 0.36. So if I zoom in a little bit, this is somewhere over here. So this is over here. Roughly, let's figure out, this is 2 divided by 5 is 0.4. So this is somewhere 3.5. So, oh, sorry, no. 3.5 times by 0.4, that is 1.4. So 5.4. 5.4. Now we need to know the other ones. The other one is over here, 1.5. So 6 plus 1.5 times by 0.4, that is 6.6. Sorry. So if we add them up, let's see whether this adds up to 12 or not. 5.4 plus 6.6, it does add up to 12 volts. So I don't think we have to look at every option now, because we now know this. Right. Okay. Moving on. Two resistors of resistances R1 and R2 are connected in parallel. What is the combined resistance between X and Y? Okay. So when we do 1 over R, 1 over R1 plus 1 over R2, we take the LCM R1, R2, R1 plus R2. Common mistake is this is still the reciprocal of effective resistance. So you still have to take the reciprocal, which would become R1, R2 over R1 plus R2, which would be B part. Okay, so a cell is connected in series with an ammeter and a variable resistor. Sorry. A voltmeter is used to measure the potential difference across the variable resistor. Resistance of the variable resistor is varied, and the potential difference and the current are recorded. The graph shows the variation with current of the potential difference across the variable resistor. What is the internal resistance of the cell? Okay, hold on. So we have a cell, internal resistance small r. We have an ammeter. We have a variable resistor, which would be like this. And what else? Potential difference is used to measure the potential difference across variable resistor. And right, okay. Okay. Now, what is the internal resistance of the cell? Right. So notice one thing over here. When the current is zero, the potential difference is 1.6. And this is the definition of EMF. EMF means the terminal potential difference of the battery when there is no current flowing. So the formula, if you remember, I think we have this in, it's over here also somewhere. I hope I can find it. No. Oh, right, get it. So E loss volts is equal to EMF minus terminal potential difference. Potential difference across the terminals of a battery when it is connected to a circuit. Yeah, and yeah, basically that's it. So EMF would be equal to the terminal PD plus lost volts. So that would mean that if there is no current flowing, EMF would be equal to terminal potential. So that would mean that our terminal potential difference would be equal to EMF. So EMF is 1.6. So this little man is 1.6 volts. Okay, now we need somewhere else, let's say this thing over here, 0.8 and 40. So when the current is 40 amps, with the potential difference over here is 0.8. So that's all we need. So EMF remains as it is, but terminal potential difference depends on the current flowing through over here and the R of this one. We don't need that because we already have IR over here, but the I small r due to this thing, that is also being used over here. This is the lost volts, by the way. So terminal potential difference is given as same formula, 0.8. Sorry, 1.6 equals to 0.8 plus 40 milliamps times by small r. So 40 milliamps is 40 divided by 1000 times by r. Just to be very clear what I'm talking about, this is EMF terminal potential difference plus I small r. That's what this was. So 1.6 minus 0.8 is 0.8. So 0.8 times by 1000 divided by 40 is R. So 0.8 times by 1000 divided by 40, that is 20 ohms. So 20 ohms. Which list contains only fundamental particles? So fundamental particles are quarks and leptons. So quarks and leptons. Quarks are up charm top, down strange bottom. Leptons are the electron, muon, and tau, and then we have the neutrinos as well. Beta. Okay, right. Antineutrinos, baryons, neutrons, electrons. Wait. No, baryons are not fundamental particles. Mesons, nope. Mesons are made up of quarks, so no. Positrons, quarks. Hadrons, protons, no. Hadrons and protons basically are built of quarks. Quarks, positrons. Positrons are anti-electrons, basically. So that those are also considered. Neutrinos, leptons. This row is the only one. Correct. Okay. Which statement explains why the alpha particle have discrete energies but beta particle have continuous range of energies? So the only reason being is that the beta particle have to share that energy with antineutrinos. So we have this. No. It's in the frequently examined questions, because this also comes in paper 2. So wait, let's show you somewhere over here. Okay. Emitted with a sorry. Yeah, okay. Different energies, because the energy released in the decay is shared between the antineutrino and the beta negative particles, and the momentum of these particles can vary. So basically, this is the reason over here. The energies are shared between them. So for alpha particles, that's not the case over here. So beta particles have a much smaller mass, and alpha particle means beta particle can be emitted with a larger range of velocities. No, it says discrete, so it doesn't even do that. Only alpha particles experience repulsion from the nucleus, which is dependent on the number of protons in the nucleus. No, this has nothing to do. Only beta particles with another are emitted with another lepton, antineutrinos, or neutrinos in the case of beta plus, and some energy is transferred to the other lepton. This is correct, but let's see the other one. Only the energy of alpha particles is discrete because the composition of alpha particles is always the same. Composition has nothing to do with that. A hadron consists of antiquarks that are all identical. What is a possible value in terms of the elementary charge E for the charge on the hadron? Okay, so usually the up charm top have plus 2/3 E charge, and down strange bottom have minus 1/3 E charge. But the antiquarks, up charm top anti will have minus 2/3 E, and down strange bottom anti will have plus 1/3 E charge. We have consist of antiquarks that are all identical. We're talking about the hadron. So if we have up charm top, either one of them, you see they're all identical. So either it's up anti charm, anti charm, up. Same thing, charm, top. So you have 3 times by minus 2/3 of E. So this will be minus 2E. If you have any combination from down strange bottom and 1, so that is plus 1/3 E times by 3, so that is going to be 1E. Both of these, okay, so 3 minus 2E is not there, plus 1E is there, so this is the only correct over here. All right, so this is the end of this paper. Hopefully, I've been able to explain all the questions properly, but if you still feel that I made a mistake somewhere, or if I couldn't explain a certain question properly, do reach out in the comments and let us know, tag the time or at least the question. I'll try to explain that again. And do check out these resources that we have shared on the Patreon. I will give you the link in the description again. And as you have already seen, this was very helpful in dealing with this paper. We will see paper 2 questions also, but in the next video, we'll cover the paper 1.2 and 1.3. All right, so see you in the next video. Bye-bye.